Welcome to the session on applications of forces, review exercises. The objectives for this session are to review previous topics through exercises, namely, understand friction and the coefficient of friction, use F less than or equal to mu r, and solve problems which involve rods in equilibrium. We will now solve the review exercises shown on your screen. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at the first exercise. A particle of mass 0.5 kilograms is sliding down a rough slope that is inclined at 30 degrees to the horizontal. The acceleration of the particle is 0.25 meters per second squared. Find the coefficient of friction mu between the particle and the slope. So let's solve this. We have our mass, which is 0.5 kilograms. Our slope is inclined at 30 degrees. The acceleration down the slope is 0.25 meters per second squared. And we're required to find the friction, or the coefficient of friction, mu. Now, if we resolve perpendicular to the slope, we have r equals 0.5 g times cos 30 degrees. And this implies r equals 4.243 ... We've here, of course, substituted g equals 9.8 into our expression for r, or our equation for r. Now, if we use the equation of motion, F equals ma, and we resolve parallel to the slope, we have 0.5 g sine 30 minus mu r equals mass times acceleration. The mass is 0.5, and of course the acceleration is 0.25. So substituting in the various parts, so g equals 9.8 is substituted here. Sine 30 is also substituted in. Sine 30 equals 0.5, giving us 2.45. The value of r has just been calculated, and we can plug that in. 0.5 goes here, and the value of the acceleration goes here. And we can now solve for mu. And rearranging this equation gives us that mu equals 0.548 to three significant figures. Now let's take a look at the next exercise. A uniform beam AD with length 10 meters and weight 50 kilograms is resting horizontally on supports at B and C, where AB equals CD equals 2 meters. When a workman of mass 90 kilograms stands on the beam at X, the reaction at C has magnitude 3 times the magnitude of the reaction at B. Model the beam as a rod and model the man as a particle to find the distance AX. Now let's consider the diagram and add some more details to it. Since the length of the beam is 10 meters and AB equals CD equals 2 meters, we have that the length of BC is equal to 6 meters. The weight is equal to 50 kilograms. So therefore, the weight of the rod acts at its midpoint, since this is a uniform rod, as shown. Notice that since force equals mass times acceleration, And as the mass of the beam is 50 kilograms and the acceleration due to gravity is given by g, we have that the force equals 50 g newtons. The reaction at C has magnitude 3 times the magnitude of the reaction at B, and this is given as shown. The workman stands at X, and since his weight is 90 kg, the force acting at the point X is 90 g newtons. Now, since force equals mass times acceleration, and as the mass of the workman is 90 kg, and acceleration due to gravity is given by g, we have that the force acting at X is equal to 90 g newtons, as shown in the diagram. So now if we resolve vertically, we have that RB plus 3RB equals 50g plus 90g. And so we have that 4RB equals 140g, which implies that RB equals 35g. So the force acting at C equals 3 times 35g, which equals 105g, as shown in the diagram. Suppose that the distance from A to X is equal to x meters, as shown. If we take moments about A, we have, and notice that the rod is in equilibrium, so the clockwise and the anti-clockwise moments are equal. So taking moments about A gives us 50g times 5 plus 90g times x equals 35g times 2 plus 105g times 8. These, of course, are the anti-clockwise moments. So the anti-clockwise moments, we have 35g times 2 plus 105g times 2 plus 3, as shown. And this equals 50g times 2 plus 3. Plus 90g times x. And then tidying up gives us 910g equals 250g plus 90gx. And tidying up gives us x equals 7.33 meters. This brings us to the end of this session. If you have understood its contents, you should be able to understand friction and the coefficient of friction, use F less than or equal to mu times R, and solve problems which involve rods in equilibrium. Thank you very much for listening.